Hey,
So hi.
hey, how's it going?
Oh yeah. Um. So do you ready for the problem?
Yeah, sure, let's go.
Yeah. Okay. It's my turn. Let me read the problem for you. Um. So given.
We need numbers. Right. So first off, this is C++.
And
I'm
by the
also
way,
familiar.
so the
Yeah,
answer should be ordered in decreasing order, right?
decreasing order of frequency. Okay,
Yes.
yeah. Yeah. So we can just iterate. Um, to what this does is we can iterate through the hash map, put the values in a row, and then sort it later. If that's
Mhm.
so. I'm not the most familiar with C++, although I think I do remember a good amount of it. But to split a string and strip punctuation, let me. I would have to Google that. Document, and then as soon as I
Yeah,
find
I
a white
think
space,
you
I
can
will
choose
keep that
whatever
word.
programming
So
languages you're familiar with. So it's okay
okay,
for me. Yeah.
oops, yeah, sure. As long as you're cool with that, then do you mind Python or is that good with you?
Yeah, I think I seldom use Python, but I think you don't need to read that. Just
Okay, yeah.
okay,
All right.
result. Yeah, it's okay.
Good. Okay, that's fine. So to start off, so do you if C++ isn't that bad, it'll probably give me a bit more practice into
Yeah.
adding into. It's probably a bit too easy in Python. So it's so first off, I'm gonna alphanumeric. Let me check.
Yeah, you can write it now. Yeah, we will fix later if it does. It's okay. It's okay if you don't remember the method. Yeah.
Okay, cool. So if it is alphanumeric, then token plus equal .i. Else, if it's not alphanumeric, then we actually token dot to lower whatever. Okay. So as long as alphabet character we added to the token, else actually don't need this. Else, if it's not a alphanumeric character, then we result push back the token and then add it to the vector, and then we will set token to be an empty string, and this should return. So just to make sure this works, you have a token.
So I think, what if the document is like there is a comma in the middle of the word, so you will push the first four characters and the last O as two separated words in your tokenize method, right?
Right. That's true. Other end, it'll be two separate words, right? So at the end for the last one, if token so let's see, this one, it'll go through it, it'll add HELL, and then
I mean, this should be
it should be one word?
Only one word, yeah, not two.
Oh,
yeah,
one word.
Yeah.
Oh,
So the words are only separated by white spaces. Any punctuation, yeah.
Okay, and we have to remove this comma, right?
Yeah.
Okay, sure. So instead of that, it'll just be white space, and then if it's white space, oh, oops. If it's white space, we add if it's not white space, and actually that was right. Hold up. So if it's alphabet character, we add to it. Else, if it's a white space, then we do something else. Can you have situations where it's like two white spaces like this, or?
Yeah, it happens.
Okay, it happens. Okay, sure, no problem. So, okay, so let's see what this looks like. So it goes through this document. If it's an alphabetical character, we add to the token. If it's a white space and the token is not empty, we add it to the result set and then we reset token. So
Yeah.
for the example we brought up, so basically we go through it, add to token, add to token, add to token. This punctuation is skipped.
Yeah.
And then we get to O, and then we add to it. And then at the end, if we're at the very end, if token is something that we add to the result set.
Yeah. Yeah, makes sense.
All right, so now that we have this, all we have to do is we let's move it up here. And then after we get a words, we can get a hash map. Hash map in plus is a hash map.
Yeah, you can use it. Yeah.
I think that's what it was.
It's okay.
So we go through the little words and then we check if it's in there. We map that count.
Okay. Yeah.
I think it's count. No, what is it? If you remember.
Yeah, you can use find and
okay.
Yeah, words I if it equals to the last iterator. Yeah. If
Oh, sorry. Go on. I don't remember the syntax.
Okay. It's not important. Yeah. If it doesn't exist in the map, in the hash map, then it will return the end iterator.
Okay. If that's the case, then you set it to 1. Else we simply just increment the counter. So this goes through it. If it's not in there, we set to 1. Else it increment. Okay. Now the last part is to sort it. Several ways you could do this. Expecting a vector of vectors. There's this. I'm just trying to make it more efficient.
You can start with the most straightforward way to sort it. You can start with it.
Um, okay. Um, so
If you don't familiar with the syntax of C++, you can write Python code, I think.
uh, we're almost there. It's just this last part, right? So
Okay.
I'll just store here for a second. So I'm gonna sort the words actually, and then I think what you could do is Boolean return better. And that would work with that though.
Yeah, I know.
Yep. So actually use words and so for it so push back the word and then we also push back count.
But it's integer, right?
Right. Should it be string to convert to a string?
Yeah, it should be.
Okay. So after we do that, we just result that pushback temp, and then we should be good.
Yeah.
I don't know if the syntax is right for this, but we can give it a shot, I guess.
So yeah, I think your basic idea is correct. So what's the time complexity of your method? Yeah.
Right. So the time complexity to first tokenize should be O n, where n is the length of this O n. Yeah, it should be O n actually. So this for loop will where n is the length of the string. That's a time complexity. It will go through n times lower if it's yeah, pushing back your vectors is O1, and then yeah, there should be O(n). Base complexity would just be O(n) as well.
And but in the third step, you use sort.
Right. In this sort step, right, this would be sort is it's the number of unique words in a document. So let's just say that's A. It's the number of unique words in the document. Okay. Actually, there's something wrong with that. There shouldn't be when I'm sorting it. There shouldn't be duplicate words with words. The vector contain duplicate words. To remove the duplicate words, all we had to do is I guess we can. Is there something like now that please should return?
Actually, not. Yeah.
No. Okay. Yeah. But you can just iterate to it somehow, right?
Yeah. Okay.
But yeah, to sort it would be okay, where k is the number of unique words. Sorry. Okay. Okay. Log K.
Yeah.
Where K is the number of unique words.
Yes.
That would be the sort step, and then the last step would just be once again unique words for each one push it back.
Yeah.
Okay.
Yeah. So do you think in which step we can do a little bit better? So in which step you can keep polish your method?
Right. Which step can we possibly method? First idea is maybe there's some better way than a sort. I'm not sure if that's possible. So you gotta return this in descending order. After we count the number of times it occurs, we would have to sort it. Yeah. Which step could be better? If it's not the sorting, I mean, this has to be at least ON and at least OK. So how could you make this? You don't have to sort it.
But the result should be sorted. So maybe there is another way, better way to sort your results.
I mean, I'm thinking if you really want to, maybe you could like keep a heap or something. So, I mean, that might be going a bit.
Yeah, you can start with the idea of trade of space for time. Sometimes we make this reasonable trade-off.
Yeah. Okay, so do you think a heap is like the right way to do that, or?
By the way, do you know bucket sort?
Oh, bucket sort. Oh yeah, that's
So because the number of unique words are not that large. Yeah.
Okay, bucket sort. I do remember some bucket sort. I think I learned in a class a bit while ago.
Yeah.
Bucket sort. So do you want to? Bucket sort. So you separate things into different buckets and then you sort the bucket.
Yeah.
How would that be effective?
Yeah, because we separate words which have the same number of occurrences into the same bucket, and then we just need to traverse in reverse order of all the buckets. Yeah, in the reverse order.
All right, that makes sense. Okay, so I guess in that case we can use another map. We can yeah, I guess we can use another map. So this would be an vector. So for example, this would be something like
yeah.
So we will go to for words has to. There should be something that can
Yeah, you can suppose so.
Right, suppose so. So for int I equals 0, I less than 1 side. Plus. Then bucket. Um, number of occurrence if so if the bucket already exists, if the bucket already exists, then we will. If it doesn't exist, we'll create a new bucket, and then this would be. And then bucket occurrence this bucket. Else we simply bucket or oh, am I missing something? There we go. So using this bucket sort, then the time complexity would be this O should just be O K and K is just the number of unique words, I guess, instead of O K log K.
Yes, you are right.
Yeah, you get extra space. You use extra space as a trade-off for the increase in time complexity.
Yes, yeah, exactly.
Cool. I don't know if this will compile, but
yeah, I think there might be some wrong syntax. So
yeah, that's not a problem.
Yeah.
Cool. Yeah, that's cool. Thanks for that. Yeah, I should write that down. Bucket sort. I forgot about that actually. Yeah. You want to move on to your question?
Okay.
Yep. So, do you want me to go over it, or would you like to read it?
Yeah, I haven't read it. Yeah.
Okay. So, basically, we're given like a string of brackets, right? Mm-hmm. And then if every open bracket is met with a closing bracket after it, then this becomes valid. Yeah. This is valid. And if these two are matched, but if you have an open bracket and it doesn't have a pair, it's just invalid. So what we're trying to do is find the number of invalid brackets again. So this is valid, so invalid, so this will return 0. But this bracket right here is invalid, so we return a 1.
Okay, I got it. So
it's like you need to add one more bracket to make this.
Yeah, so the problem is about to find the minimum number of brackets to make the given string valid.
Mm-hmm. Yeah, to make it valid.
Okay. So my first idea is to use a stack, and when it comes to it comes to open bracket, so we push this bracket into the stack, and when it comes to a closing bracket, we um, we grab an open bracket from the stack if it has it, um, if it doesn't has any if there's if no open bracket in the stack, then we push the closed bracket into the stack as well, and the answer would be the size of the stack after we go through the text.
So, sorry, you mentioned that you grab an open bracket from the stack. You just grab which one you grab, the top one or
The topest.
Mm-hmm. Okay, yeah, that makes sense.
Yeah. So basically, suppose n is the length of the text, and we just go through. Actually, we don't need n. For each character in the text, and we use a stack. If the current bracket is an open bracket, so we just push it to the top of the stack, and
Okay.
otherwise it means the current character is a closing bracket, and we try to grab if the stack is not empty. Hello? Hello?
Hello?
I'm
Okay,
sorry,
yeah.
my connection is not stable. Yeah, so
Okay.
yeah, I think I've finished it. So the basic idea is we go through the text in order, and when it comes to an open bracket, so we just push it to the top of the stack, and otherwise if it is a closing bracket, we try to grab an open bracket from the top of the stack. If the stack is empty, we push the the closing bracket to the stack, because this closing bracket is not able to erase. For example,
Yeah.
if the text is just as the first example, so for the at the first character we push it because it's an open bracket. we push it to the stack, and now the stack has a character, has only one character.
Yeah.
And
Okay.
at the second character is still an open bracket, so we push it to the stack. The stack has two open brackets. So for the third character, because it's a closing bracket, so we grab an opening. I think oh shit. Because the stack may have closing brackets, so we have to so what I'm doing is to check if the top of the stack is a closing bracket. So
okay. If it's an open bracket, you push it on. If it's a closing bracket at the top, you push it.
If the top of the stack is a closing bracket, that means all the characters in the stack are closing brackets.
Okay. Looks like it works. You can try running this.
Yeah, I can. Try the first example. Oops. We should include
Did you run it?
Yeah, no. It's one. So for the second example, it's supposed to be 0.
Yep.
So for the third, should be 2. So now we can just run test. So okay.
Awesome.
Seems okay.
Good. How can you improve this answer? There's actually a small optimization that I guess you can make. Actually, yeah. There's a
yeah. Because maybe we don't need to use the stack. We just need a counter to keep track of the number of open brackets we have. We need a counter initialized to 0, and if the current character is an open bracket, we increment the counter by 1, and if it's not, we don't need this. And if it's a closing bracket and counter is greater than 0, then we decrease the counter by 1. Otherwise, we oops, oops.
Mm-hmm.
So we need another auxiliary variable answer to keep the answer. Yeah. So answer is the return value. So if counter is non-positive, we uh, let me see. If the current character is a closing bracket, so we decrease the counter by 1, and if the counter is non-positive, it means there are some closing brackets we're not going to erase. We can't erase these brackets, so we just add the number to the result.
Okay.
And set the counter to 0. 1, 2, 1. Oh.
Okay. That makes sense.
So 1 minus 1 minus and 0 1. Yeah. So we can run the code. Oh, should be 2. And if we run tests, so it's supposed to be okay.
Okay, cool.
Yeah. So yeah. May I ask where you're from?
Sure. I'm from Canada actually. Where are you from?
Yeah, I'm from China.
And
Yeah.
are you in China right now?
Yeah, actually, currently I'm studying in China. Yeah, I am Chinese as well. Yeah, so yeah, I mistook you as Chinese as well.
No, I can speak some Chinese. It's not very good.
Oh, really?
我的中文还能听懂，能说一点，但是不是很好。
Yeah, cool. I can hear you. I can understand you.
Okay, cool. Are you a undergraduate?
I'm doing my master's in computer
Wow.
science. Yeah, so
Okay.
I applied for a summer internship at Facebook. So going to take my interview next week. So it's a little bit nervous.
Yeah, that's pretty cool actually. So what visa will you come to the U.S. under?
I'm not going to the U.S. because because the Facebook recruiter asked me to interview in London. Yeah. Facebook has an office based in London.
Oh wow.
Yeah.
Where in China are you from?
Are you sure you know any places in China? So I'm studying in Nanjing city. So
my mom was she was born in Nanjing, so
oh
yes.
cool. Oh so
Cool.
it's really an honor. So
I was from Ansan.
okay.
I was from Liaoning.
Okay, cool. I know it.
I came to Canada when I was like 6 or something, but yeah, that's pretty cool. Um,
So
any
mm-hmm.
feedback for me for my question or my interviewing skills? Anything I can improve on? Do you think?
Yeah. So you usually use Python on daily basis. Oh,
Hmm.
so
I for my interviews I use Python. Yeah.
yeah, but um, I usually use C++ because I write C++ for roughly 5 years.
Oh wow. Yeah.
Yeah, because so because I participate in I'm not sure if you know ICPC.
I think I heard of it.
Ah,
XCPC is a competition, right?
yeah, ACM ICPC.
Oh,
It's
oh, okay, yeah, that's
yeah
pretty.
yeah. So actually, I have little interview experience, and my communication sucks as well. So I do need
Hey,
practice.
yeah. I mean, if you participate in ACM, all these questions are like super easy. Any interview question you get will probably be really easy for you. ACM is hard.
Yeah,
So
kind of easy. But you have to pay attention to your. You have to write bug-free code. You have to pay attention to your code style, and the name of variables should be make sense. It will be easier.
right.
Yeah, for the interval and
Yeah,
competition
wow.
and interviews are totally different. I think.
Yeah, but yeah, I'm sure. Well, at least you don't have to worry about getting the algorithm right, getting the question. You have lots of experience with that, so that's good at least.
Thank you. So I'm not sure if you want um, to discuss with me. You can we maybe can add. Do you use any social media? Well, maybe we can discuss
I
later if you want.
sure.
Okay.
Yeah, that would be cool. I use Facebook in China is blocked, right?
But I can use it.
Oh, did you have a Facebook account?
Yeah. You can. My name is Tong Wei. Yeah.
I don't know if I can find you. You're pretty far.
And
Yeah.
let me see.
I can send you a link to my profile.
Yeah. Okay.
I'm just yeah, I'm doing most of this to practice for my internship, which is coming up. So
Okay. So. Okay. Got it.
yeah, let me know whenever we do some questions together. It will be I think that would be really awesome. Especially since you have so much experience with this kind of thing.
Yeah. So basically, I think I sold about 5,000 of algorithmic programs by now. You know, yeah, we uh, we we practice a lot. when I was doing my bachelor's. So
Yeah. Wow.
uh,
Did you do bachelor's in Nanjing also?
no, I I did my bachelor in Suzhou. Do you know Suzhou?
No, no, that I don't know that one.
Oh yeah, okay. It's a city near Shanghai.
Okay, I know Shanghai. Yes.
Yeah. So it's really nice to meet you.
Yeah. Nice to meet you. It's great talking to you.
Yeah.
Let me know if you talk anymore anytime. Just add me on Facebook and we can connect anytime.
Okay. 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 Well, let's keep in touch.
Keep in touch. All right. Okay.
Okay.
Bye bye.
So bye for now.